Okay, so we're coming towards the end of our series of videos on non-parametric tests now. I had intended this to be the final one, but having read back some of the things on Wilcoxon and Wilcoxon rank sum test, I would like to go back and revisit those in a little bit more detail and summarize, which will come in one final video after this. But I probably need to mention that all these figures for the tables here are about probabilities. And there are one or two things I wish I'd mentioned at the time but didn't, which I'll cover in the next video. And actually will also mention here as well because it's relevant to what we're doing. Okay, so let's get on with it. The idea is if you basically have numbers which are, let's say these critical values can be worked out using probabilities, which I'll explain in a future video. All we really need to know at this stage for practical purposes is if your set values of n go beyond 20, you can't use these numbers which are given to you in the exam. So you have to use something called the normal approximation. And thankfully that is given to us in the exam, how the normal approximation works. Basically the values of W plus and W minus, which is interesting in itself, are basically distributed, can be taken from the distribution which have got mean quarter n, n plus 1, and variance that 1 over 24n, n plus 1, 2n plus 1. So that's what we're going to use, and this is how it works. Now, questions, you're unlikely to be asked a question from scratch with this because, of course, by very nature, 20 is quite a large number. So probably you're given some kind of summary data to enter the question. So here's a couple of examples. They're not, I should say at this stage, they're not original examples. They are actually taken from the Cambridge textbook for OCR. So shout out to them and hope they don't sue me if that I've used their video. Hopefully the acknowledgement is enough. Use their material, sorry. So anyway, let's go on to this question and on Wilcoxon side rank test. Okay. Right, so it tells us here that the sum of the positive ranks is 196 and the value of n is 32. So the first thing we need to do is work out these two quantities here for our mean and variance. The mean is equal to 1 over 4 times by n, which is 32, times by 33. Which equals 264. And the variance equals 1 over 24 times by 32 times by 33 times by 32 times 2, which is 64, plus 1, which is 65. So that comes to 2,860. That's the variance, remember, not the standard deviation. Okay, so we need to write our hypothesis because it is telling us conduct a two-tailed test. So we're going to have to write the hypothesis down. Now, notice here the question hasn't even told us what the median is. It's just told us what the sum of the deviations from the median are, or the sum of the positive ranks, not even the deviations, the ranks. So we don't know what the median is, so we can just write it in words. H0 median is unchanged. And H1 is that the median is changed because it's two-tail. We'll come back to that in a sec. Okay, now this is the part I will go on to in the next video in a bit more detail, but I'd actually wish I'd noted at the time and used at the time is the fact that it is useful and conducting a Wilcoxon signed rank test from scratch to use this principle to check your values, because if you'll recall that we actually worked out both of these and then picked the lowest one when we were doing the Wilcoxon test, and use the fact that that's just the sum of the counting numbers. It's so it's just half n plus 1. So that's a useful check when you're doing those results. Why am I mentioning it now? Well, because we could, if we wanted to, work out the sum of the negative ranks using this. We could just say that W minus equals to the different, well, we could use, if we start from scratch, W minus to W plus will be equal to half times 32 times 33. So that gives us W minus is equal to half times 32 times 33, which is equal to 332, which would have been a bigger one, so we would have picked W plus in that case. However, when we're dealing with the normal approximation, we don't really need to work out the other one, because we can basically test on the opposite end of the tail. So we'll just use whichever side of our approximate normal distribution we are, and we'll find in a moment when we do this, in fact we can see it now, because our mean is 264. Okay, but our median, which is the same as the mean in this case, of course, because it's symmetrical, 264, and our W minus W plus value is on this side of the distribution, which is 196. So we want to be working that probability out. However, not quite, because we have to do a continuity correction, which we'll see in a moment. It'd actually be 196.5. Okay, and had they given us, for some reason, given us the W minus number, we wouldn't have needed to work out the other. We could have just worked out this number on the tail, yeah, here on that side. Okay, so W plus or W minus can occur on either side of the tail, but you just work with whatever you're given and deduce that we're on the left hand side of the tail here, because the mean or median, or no, we do mean here because it's a normal distribution, the mean is 264, which is greater than the value of the positive rank, so we're dealing with the left hand side of the tail. Okay, so I'm not suggesting that you need to do this. I will mention it again in the next video, but it will be a good check in questions when you're doing the Wilcoxon signed rank test from scratch. Okay, so we're going to be working with the 196.5 because of this thing called the continuity correction, because W minus, the distribution of W scores for W minus, is discrete. Okay, whereas obviously the normal distribution is continuous. So this thing is called a continuity correction. We've seen it before when we did the binomial approximation using the normal distribution, which again is a similar idea that binomial's discrete, and for large values of n, so close to 0, where p is close to 0.5, you can use the normal distribution. So here we're using the normal distribution and we need to do a continuity correction. So let's just say probability, and it was the sum of the positive ranks that we got, W plus is less than or equal to 196, because we're dealing with the original distribution, is equal to, let's call this, let's just define X to be the distribution, which is the approximate distribution for W, which is mean 264, but variance 2860 square root squared. Just to emphasize, the standard deviation is a square root of that. So using a continuity correction, we always kind of extend backwards with a continuity correction. So if we had 196 here, we're going in that direction. Always extend backwards. So that gives me the 196.5. We'll just kind of move it further. It makes the number line bigger, basically, the continuity correction. So that gives us the probability that x is less than 196.5. It's kind of arbitrary if I make it, because I'm now with the normal distribution. 196.5. It's arbitrary if I have a strict or non-strict inequality. Or inclusive inequality is arbitrary, but I've written it like that. So now we can use our tables. Not our tables, we can use a calculator. So we go for menu, and we want normal distribution, normal cumulative, so that's 2. The lower value, well, this is one of these situations where we just have to put an unlikely smaller value. You don't have to go over the top. I have people putting in -1,000 in and things like that. I would have thought here we're okay with 0. Okay, for the upper value, we've got 196.5. The standard deviation is equal to, the mean is equal, no, that is a standard deviation. So the standard deviation is equal to the square root of 2860. And the mean is equal to 264. And that gives us the number 0.103. 0.0103. Okay, so that's 0.0103, and that is less than, greater than 10%, and it needs to be 10% because two-tailed test. That's the critical value for a two-tailed test. That's the threshold. So two-tailed test. So it's greater than 10%. So it's because for two-tailed test we need to take it both each way. So we need 10% that way and 10% the other way. So it's greater than 10%. So therefore, the conclusion we do is we do not reject H0. There is insufficient evidence to suggest a change in the median. Okay. Right, so now let's do an example with the Wilcoxon rank sum test using the normal distribution. To recall, the Wilcoxon rank sum test is basically you have two sets of data and you're comparing the distributions, more particularly the median of the two distributions, but they're not paired data, and most often you don't even have the same number of data values in each set. In this case, you've got m is equal to 12 and n equals to 20. Okay, and it hasn't, this particular question hasn't asked us to set up the hypothesis, but I will do anyway. H0 is the median difference equals to 0. And H1 is that the median difference is more than 0. More than 0. So that's not specifically asked for, but it's always the best thing to do, generally speaking, get in the habit, because people leave it out at their peril. And you'll recall when I said that when I twittered on about the W plus and W minus thing, it was unnecessary to work out the other one here. Likewise here, it's not necessary to, if you look at the actual recall the test that we have to do, it's not necessary to work out the other quantity. That quantity there, and I will talk about this in a final mopping up video following this, that quantity there is what RM bit would be if you ranked in the opposite direction. So you're taking the smallest and largest. But again, if you happen, because we're approximating to a normal distribution, if you happen to be at the other side of the normal distribution, you just test this side of the tail and have done with it. Okay, so we don't need to worry about calculating this measure here. We can just work with what's given to us, the normal, the mean and the variance of our normal approximation. Make sure we use a continuity correction, and we're done. So the mean is equal to half times by 12 times by 12 plus 20 plus 1. That equals to 198. Okay, and the variance equals to this quantity here. That's 1 over 12, 12 times 20, 12 plus 20 plus 1, and that equals to 660. Okay, so that's our normal distribution. So let X be the normal distribution here, which it approximates the value of RM, so 198 and 660. Okay, now all we're going to do is we want to find the probability that RM is, and our value of RM, let's draw the sketch of it. The value of RM is 240, which is above the mean. So our value of M is 240, which is above the... So we're 240 there, but we're going to do the continuity correction in a moment. So we're looking at this end of the tail because we're above the mean. The mean is here, which is 1, or median, same thing, 198 for the normal distribution, 198. We need this, we want to test what that probability is, but as I say, don't forget the continuity correction. We're always extending backwards, so if we've got 240 here, we extend backwards by 0.5 because we're approximating a discrete random variable with a continuous random variable, which is 2. So we're going to go extend the line backwards. 239.5 is the number that we need. So the probability is above 239.5. And now we go to our calculator again to work out that value. So menu 7 on the, let's press menu 7 on the thing again, press 2. So the mean is 198. Well, we're talking about an upper tail now. We want it to be greater than, so we're looking at tail, sorry, I'm jumping the gun a bit. So we're putting the upper value in. Now the variance is 660, which the square root of that is 120. If you put something like 1,000 in, it's going to be way bigger than it needs to be to get this. So let's put 1,000 in there. My apologies, I obviously want the lower tail to be 239.5. and the upper tail to be something unlikely big. 1,000 is certainly big enough. And the standard deviation is the square root of 660. The mean is 198. And I've got the value 0.053 or 0.531. We should always give three significant figures, really. Okay, now that is less than 10% because it's one-tailed and we've got a significance level of 10%. So that's less than 10%. Okay, so the conclusion is we reject H0. There is sufficient evidence to suggest that there is an increase in the median, there is an increase in the median between the two groups. So that's nearly it. As I say, I'll mop up with a final video trying to explain where the earlier bits with the significant numbers from the tables come from, although it's probably not absolutely necessary for the course, but I think we ought to really. And just other things, just thinking about it now, we had this number 240. We'll find that if we worked out if we worked out the quantity 12 times 20 plus 12 plus 1 minus 240, we get the number 156, which would just be the other end of the tail. So we don't need to work out that quantity for the normal distribution. But we'll talk a little bit more about those kind of little issues in the final video, in particular with how the actual critical values come about. Okay, that's it. I hope you found this useful. Goodbye.